Hi, everyone. Welcome to our webinar on the practical use of AI in engineering. My name is Jack Koor, and I am the research director at Payload. Joining me is Marco Witzmann of ValiSpace. This is going to be a super interesting discussion, I think very relevant to a lot of people's jobs right now. So we're going to try to make this a very open discussion, and that means if you have a question about AI, a question about ValiSpace, a question about engineering vis-a-vis AI, just throw it in the chat and we will try to get to it. I can't promise we'll get to all of them, but yeah, with that, we're gonna jump into it. And welcome, Marco. Appreciate you joining us here. Would love if you could just introduce ValiSpace and yourself.
Yeah, thanks for having me. So my name is Marco. I'm one of the co-founders of ValiSpace. I used to work as a satellite systems engineer at OHB in Bremen for several years and was working actually on MTG, which is like Europe's biggest weather satellite. At the time, roughly a 2 billion euro project. And when I was working there, we had 7 years before launch, we had around 20,000 official documents and 300,000 unofficial documents that were describing the spacecraft. And that's when I noticed, maybe that's not the most efficient way of doing engineering. And when I found out that this was a problem that was inside both not only the company, but also in the entire industry and even across other industries, I decided together with my co-founder Louise to create ValiSpace as a company. So ValiSpace is a collaborative engineering software. It basically covers everything from requirements engineering and systems engineering. So from the inception, when you have your idea and you basically are at the napkin stage, all the way to then developing the idea to a verified product. And in this, we have like what we call the ValiAssistant, which is an AI assistant that helps you basically go through all of these stages. And that's basically ValiSpace today serves like hundreds of customers across different kind of industries, but space is definitely our home turf where we started and still one of the big customer bases that we do have.
Right. So the AI and LLM model is key to the functionality with ValiSpace. Are you using what LLM model are you using? Are you using OpenAI or a different one or your own proprietary one?
Yeah, so we basically started with OpenAI and are using the API from that. And then we're combining that with a mix of smart prompting and other things. We also have our own functionalities. So the ValiAssistant itself, you have to imagine it's more of a functionality to help people get stuff done. So sometimes that stuff might be AI powered or LLM powered, sometimes it's not. So for the user, they don't actually care how it's done, right? But there's different ways of solving it, and some of them are powered with the OpenAI API. We are currently moving also some functionalities to a local model so that people could basically, even if they have only an on-premise solution, so if they worry about the data being in the cloud, also being able to run the AI capabilities directly on-premise.
Great. So, okay, so right now you're using kind of the OpenAI LLM model and incorporating that in your software solution. And can you just kind of walk us through, how that works, what kind of applications it can be used for, and why it's important for engineers to introduce this into their workflow?
Absolutely. So the way you have to imagine the ValiAssistant work is that you always have basically that assistant that helps you do things. So you don't have a chat interface where you just ask it random stuff, but basically imagine that you have a bunch of requirements that you get from your supplier, right? Now you have maybe a few hundred requirements and they're obviously inconsistent, right? So the first thing that you usually do is you try to find inconsistencies. So instead of doing that by hand, you can just like click on the requirements, import them with the spreadsheet, and then say like, okay, show me the inconsistencies between these requirements. And then you get like a suggestion of which requirements are content-wise probably inconsistent. Next step from that is that you usually want to improve your requirements, right? So you'll have these requirements, but the requirements you want to work against are probably more concise, more testable, and so on. So ValiSpace allows you to go ahead and, after doing these kind of quality checks, basically also improve the requirements. Next step is you're going to break down those requirements, right? So you take those requirements and you're trying to break them down into like a system structure. So you have a high level requirement, you'll start having subsystems requirements, component requirements. Also here, the LLM basically, or the ValiAssistant better said, helps you do that kind of breakdown. And the logic is always the same. The ValiAssistant will suggest certain options for you, right? Will basically tell you, hey, that's my best guess. And you're going to be able to like edit on the way. And then save them in, and then you'll do the next step. And again, from there, you can go, okay, hey, I read these requirements. Maybe these are the kind of subsystems that your system has. And you'll be like, yeah, these 5 are fine, but these 2 actually, I'll have to rename them. And then you'll do that, right? And then you'll do the next step and go ahead and do that breakdown. And this way, the assistant is always there for you to basically help you get the things done that you anyways have to do, but without getting in your way, in the sense of that you have to like trust its output 100% or something. It's more, you have to imagine it's a bit like having a junior person all the time at your side. You can say, hey, look for inconsistencies in the spec, and he'll probably not find all of them, but he'll do a 90% good job, and this will already be helpful for you. You'll say, hey, make me a summary of all of these requirements, right? And write like a half pager, and it'll just do that, and the summary is going to be quite good. You're going to say, like, find me all the parameters that are mentioned in here, make parameters in my model, and he'll probably catch 95% of them, and that's going to be a good starting point. And then you can like tweak the last few parts.
Got it. So it's really more of a co-pilot. There's always a human in the loop. There's an engineer in the loop, but it can help with creative thinking and suggesting ideas, suggesting different possibilities, and taking some of the mundane tasks too out of your hand. But there should always and will always be kind of the engineer, the human engineer, who is double checking everything and or is taking the idea that was generated through ValiSpace Assistant and decide whether it's a good idea or a bad idea, because there could be bad ideas that are generated too.
Yeah, absolutely. And I think it's the same way that if you had your junior colleague, you would never just take his word for it and then just go and build things, right? It would go into review loops. You would try to like, you would do all the necessary steps before you release documents, before you go ahead and build things. And I think that's the crucial thing to understand. I think there's currently in the media, there's kind of the 2 extremes, right? One of them say like, oh, AI is going to just take everything on, right? Like you're just going to press a button and everything is going to be done. And I don't see that future happening in engineering, right? I don't see that you just basically say what you want and then you click a button and at the other side you'll get whatever, a result out of it. And the reason is there's tons of trade-offs to be made, right? There's not a clear, better way of doing something. Sometimes you might want to go a bit faster on certain things and you can take a bit more margin out, or you want to be optimizing. All of these kind of trade-offs are things that a human needs to do, and basically it can just help you, like the software can just help you do that. On the other extreme, you'll see people saying like, oh, that's all bullshit, right? Especially when you're dealing with numbers. Like these AIs, they just hallucinate, they're just rambling, like you're never going to get something useful out. And that's also not true, right? Like you can see, I mean, the underlying models, they have read all of Wikipedia, they have read all of the articles about propulsion and so on. So if you tell it like, hey, I have an electrical propulsion system, it will actually suggest like key parameters that you should probably have a look at. So it's actually going to be useful. Whether that's then the exact ISP that you want or not, that's still something for you to decide. So I really believe that we should take the best part of it. LLMs are highly creative, and that creativity is something that is typical for engineering work. You do have to be creative, but then at the same time, you need a system in which you then start putting formulas in numbers. And that's where ValiSpace is so strong, because it combines the AI approach of the creativity of LLMs, but then brings like the formula number-driven approach, making sure that you actually do get calculations, you get the right numbers, and you do the simulations the right way, so that your product in the end doesn't explode in space.
Yeah. I mean, you mentioned AI hallucinating, and I think it is true. It's call it 1 or 2% of times it's hallucinating, but I do think that hallucinating part of AI is important to discuss here, because it does happen, and you do get false positives, and particularly in this industry and space systems, that those decisions that could be hallucinated could be mission critical, could be life or death, could be $1 million outcomes. So how do you, for someone who's hesitant, an engineer that's hesitant to just trusting an AI that could hallucinate, I don't know what it is, maybe it's a fraction of percent, but it could happen. How do you respond to that? How does ValiSpace kind of handle that?
Yeah.
problem?
I think the first thing is don't ask the wrong kinds of questions, right? If I'm asking like which part should I buy, and then you expect an AI to like have the answers to this and know the catalogs of what is exactly there and that these numbers are true, you're
Yeah.
probably wrong, right? Like that's not happening. The day that we will bring some functionality like this out, it will be based on real catalogs. We will actually like fill it in, making sure that it actually switches, right? Like we, for example, today we're connected to SatSearch where you can look for actual parts and they have actual data sheets and you can just pull them into your system, right? So don't ask like an LLM to provide things that it obviously is bad at. And this is why, again, it's not a chat interface in ValiSpace, right? Like it gives you functionalities that we know it is actually good at, right? Like improving a requirement or something like this. The second thing is, um, I mean, engineers are still highly paid and they're paid for their brains, and you should not like take that step back and take this autonomy out from people, right? In our case, for example, when you write a new requirement, right, and you say, for example, well, um, the power consumption of the electric subsystem shall not exceed whatever 500 watts, right? Um, if you write that requirement like this, then it might actually suggest to you, hey, is that in which mode is that? Is that in nominal mode? Is that like average? Is that peak power? So what the AI does is like pokes you to be more precise, right? It basically suggests, hey, the average, for example, power consumption should not be more than that. Is that the true one? I don't know, right? But the engineer now is like, oh no, what I actually meant was peak power. So he's actually getting better. He will like the hallucination or the thing that the AI came up from was like trying to take a best guess at what you were expressing and putting something back to you. And now you can decide, oh no, I actually meant peak power. I meant in standby mode. I meant whatever. And suddenly your requirement is better. So the reality is it's more likely that whatever your supplier has to build or something is now going to be back to spec. And then once you get to that point, now it gets interesting, right? Because same thing, you now still have to go and validate everything. You have to verify everything. So you still have to make sure you have calculations, that you have simulations. You have to make sure that you have test procedures and test steps and so on. And here again, ValiSpace can help, right? Say like you have 20 requirements and you say, oh, give me a test procedure that might test these. That's a great first start. You'll have like test steps that could get you through that. But then if you rely on this and you say like, oh, I bet that's fine, you sign it and let someone do it, you're not doing your job well, but you wouldn't do that with a junior engineer that you're working with either. So just trust the AI to the same amount you would trust a single junior engineer.
Yeah, I think that's a good way of putting it. And then just to double click into how it integrates into the workflow, into the dash. Is it a dashboard? Is the AI kind of integrated within the software solution workflow where you're going through requirements and it kind of pops up and you said it's on a chat interface, but it kind of pops up and you can interact with it?
Yeah, exactly. So it's not a chat, right? But it's like in different functionalities. So for example, you'll have a requirement and you can have different options of what you can do with it, rename, delete, whatever, and you can say improve, right? And that's basically a functionality that you do. So it's a bit of similar to the Google approach to AI, right? Like if you look at your Google Photos, for example, and you have a search bar and you just search like, oh, show me all the whatever beach sunset photos, and we'll just pop up a beach sunset photo. You're not thinking like, oh, I have an assistant and I'm asking it to do something. You just assume that the search box, for some reason, magically can search through your pictures and get you out the result, right? So it's part of your normal feature set, and it's just aided by AI, right? So we have, for example, right now introduced, we've just released a new feature which basically is called custom AI actions. And this even allows people to like come up with their own actions that they find useful. So as an example, we had a customer and they had to like give a lot of things to their suppliers in Germany. So one thing was, well, just translate these requirements to German, right? It's such a, it's a thing that basically inside ValiSpace takes you now a very short time to set up. But now you have all of these engineers, and instead of having to like do that by hand, you now have the AI do that, right? So it's now part of your workflow that you have in your everyday engineering.
Yeah. Yeah, and I'm not an engineer, but it probably cuts out the more boring tasks too, and allows people to focus on the really interesting stuff as well. Um, Great, and
Yeah,
then
that has been ValiSpace's philosophy from the get-go, right? Like ValiSpace is a tool, and you always say, right, a fool with a tool is still a fool. So
yeah,
it's not enough. Don't expect that the tool will suddenly make magic if you're doing bad engineering practices. What it
yeah,
will do is it will give you back that time. For example, I look through 10,000 requirements, find inconsistencies. Well, if I'm highlighting 30 potential ones and you have to like look through them one by one, and then maybe 5 of them are not one, like false positives, that's perfectly fine, right? You still saved a lot of time in the process of doing so. So yeah, it's about getting the mundane tasks out, making sure the engineer's time is freed up
yeah,
to do the actual work that helps their projects succeed faster.
yeah. Instead of going through every 10,000 of those, it'll narrow it down to the 30, and then you go through the 30, and double check everything. And one before we take a step back, or go a little higher and talk about the space industry in particular. Does the AI learn as you use it? Is that built into the functionality now, right now? I know we're still young. OpenAI is still young, and ValiSpace is still young in implementing AI capabilities. But is it like with every month, does it kind of learn your systems better and how you work better? Does
Yeah, so basically two things, right? One, with all the feedback that we get from customers, the functionalities get better. So if you hit improve requirement, and you did that in May when we were the first company to ever come out with AI function or with LLM functionalities in the engineering sector, we were the first engineering software company out there. Obviously, it was still worse than what you get today, right? So today we're like able to get better results, but that's not an automated learning process. Okay, this is like us learning from how engineers are using our functionalities.
okay.
One of the things that we have on our list for 2024 is basically, especially when you have big organizations and maybe they have 100,000 requirements where they say like, that's well-written requirements, right? According to our standards, that's what we want, right? And this is not just in general. This might be, for example, maybe software requirements should be written with this certain level of detail for us, right? Now you can then actually, you're going to be able, hopefully that's something that comes out this year, to for big organizations to then tell the system, this is what I consider good, and then basically the responses that you get back are also going to be much more aligned with that. So basically, things that are not universal but tailored to your organization, to the kind of parts that you have been using, to the kind of requirements that you have been describing, will start becoming part of your system.
Got it. Okay. Great. And we have a question from the audience. You can see it in the chat box, but the question is, do you do requirements, compliance, and verification tracking? And what he's meaning is, once the requirements are defined, can ValiSpace continue to be used?
Yeah, absolutely. So we usually say there's like three key flows that people do in ValiSpace, right? So one is specify your product, right? So that's actually writing the requirements. Then there's design your system, right? Where you're actually doing like your system design or your subsystem decomposition. You'll start to have all these parameters, put that into simulations, calculations, and so on. And then the third piece of it is actually verification validation. So in this case, you have all your requirements defined. You actually did some of your design. What you're now doing is you're like starting to make sense of how are you going to verify each of these requirements. So if you think of the V model, you're going up the V model again. And you're actually making sure that for each of these requirements, there's either a test or there's a simulation related to it. You can define even the procedures inside ValiSpace. So you can say, okay, here's a 5-step process of how we're going to do that. And in this step 3, that's where we're verifying that. And ValiSpace has one very crucial functionality in the verification that is unique to ValiSpace. It's called automatic verification. And basically what happens is, let's say you have a requirement which says the total power consumption of your spacecraft shall never exceed 2000 watts, right? And now you'll probably have calculations or simulations that actually do that, right? They go through Monte Carlo analysis and look at different cases and so on. What we do is we can connect to these kind of tools. So if it's Python or MATLAB or whatever it is, we can connect to those. And then the results of those, so maximum power consumption in any mode, is basically put back into ValiSpace. Now what you have is that specific value is connected back to the original requirement. So the automatic verification, what will happen is, imagine someone makes some change in the design. Maybe someone changed the battery or changed something else. And now basically people are rerunning the simulation. ValiSpace will automatically take that value, compare it back to the original requirement, and will then give you a thumbs up or a thumbs down, basically, if your design is still in spec with what you had designed for in the first place. So not only is verification and compliance part of ValiSpace, but we're actually closing the loop very fast because we can do this continuous check, similar to what is in the software world. In the software world, right, you have automated tests and they run all the time. They tell you like, yeah, your software is still fine. And basically we're bringing that into the hardware world, where we will check, well, your tests and your simulation results and so on, and check whether they are okay or not with what you have specified in the first place.
Right. Thank you. Thank you, Max, for the question. Remember, for the audience, if you have a question, just put it in the Q&A. It could be high-level industry questions or specific ValiSpace questions, or really anything. And I just wanted to take a step back and talk about the industry as a whole. I mean, this is AI really bursted on the scene only a couple of years ago with ChatGPT and everything. It seems like in a year and a half, we've seen like 10 years of growth where things are proliferating very fast, and the adoption rate with every knowledge-based worker is increasing dramatically. So how do you see in the space industry with space engineers, how do you see the future, maybe the next year or two, unfolding with the adoption of AI and AI tools? Do you think it's something that will take longer than a couple of years, or do you think it's going to be adopted very quickly?
So I think every knowledge worker, and also specifically in the space industry, will have touch points with some kind of an AI-assisted mechanisms by the end of 2024. I think it will not take more than a year for people to have some touch point in what they're doing, right? I would say there's mainly two key elements in the space industry where AI will happen, right? So one of them is on the product side, right? So you will use AI to figure out, okay, I don't know, you take pictures with your camera in space and you don't have so much bandwidth, and you're going to pick which ones of the pictures you're actually sending down, which one is worth taking the bandwidth. So basically real product parts, right? Or you'll have optimization of trajectories happening with AI. So these are things, I mean, they're already happening, but I think they'll happen more and more. Well, you'll have the ability of having localized chips that are on far lower power consumption, able to do these things even in orbit. And I think that's what we're going to see. And I think every engineer should be highly aware, because the fact is still, even in a new space environment, cycles are still long until your spacecraft is out there, right? And I think looking at the possibilities of what could be done even on board the day that you bring it out is something that people should read into and have like a already awareness of. But it will obviously take a bit longer, just because it takes time to build hardware, put it into space. But it will come. The other side of it is the process side. So I really believe that the engineering process is going to be very much affected by AI, and it's going to happen sooner than later. And the reason is, it's one of these big leaps forward in productivity. You're not going to be able to afford anymore to work in any other ways. We see this with big companies, right? Big LSIs and so on, who say like, okay, we have a shortage of talent. At the same time, we have stricter requirements. We have to come out faster with our things. So they have a big, enormous pressure. And if you can get, I don't know, you spec out like in half the time because it's AI assisted, well, they're going to do it. And for the new space companies, I mean, they always have to outcompete the bigger guys, and they always have to outcompete the others. And you're not going to be able to just say, yeah, well, doing it the traditional way and not looking into this. So it will be something that everyone will be pushed for. And I think this is going to happen very fast, because the tools are also evolving so fast, because the tools now give these abilities into engineers' hands basically today, right? Like you can today go on our website and like try it out yourself and see basically the results and be like, oh, okay, I guess for these kind of applications, I can already use it. Sure, in 25, 26, 27, there's going to be far more functionalities out there on the market and so much more that can be done. But it's not the thing of the future. It's something that is here today. And that's why I believe engineers are in general curious and they will go for it. And although the space industry is usually a bit lagging behind, there's no reason for them to be lagging behind in this case.
Yeah, you mentioned speeding up engineering timelines, but you also have, I mean, you also have you have cost reductions for projects. You have, potentially de-risking projects by using AI as a fact checker and finding inconsistencies, and you also have you increase the amount of creativity and expand and to be able to make your hardware better, expand the possibilities to make your hardware better. We have another question. We answered this at the beginning, but I think it is very important because people want to know the specifics of it. Is the ValiAssistant an in-house developed LLM or a OpenAI GPT-4 LLM?
Yeah,
and that,
the ValiAssistant is basically it's a combination of features, okay? And some of these features are LLM based and they're today using GPT 3.5 and GPT-4 to answer, like to be able to provide some of these answers. One of the things that ValiAssistant does is it gives the right context in the prompts that we're using on the backside of this, right? So basically, when you're asking to improve a requirement, obviously it does make sense how you asked to improve this requirement, which other information do you give in the context to improve this requirement. So we're doing some smart things there on the background. But then also some of these are not actually LLM based. So for example, one of the functionalities that we have is if you have a requirement and you have written it and then there's any value in it. So let's say, I don't know, you say the angle of the sun sensor shall be 30 degrees or more or bigger, right? Like the opening angle. Then we actually have a ValiAssistant functionality that will find these values and convert them into parameters on the back end so that you can start doing calculations with them and check them against real calculation simulations. That's, for example, functionality that we on purpose didn't implement using LLM. So it's like different methods. For us, it's just also, as we're developing the software, it's just a tool in our toolbox. We're never going to use like a functionality just because it's cool or it's a certain thing. We're always looking at what is the currently best technology to get that specific thing done that the engineers is trying to do. And today, that's often like an LLM functionality using the OpenAI API. But as I said, we're already working on local models because for certain applications, local models might actually be better or provide more privacy for people who are like concerned about where their data is going.
Yeah, so let's talk about that too. So if there's let's say it's a national security projects, or there's a lot of ITAR restrictions on a project, and folks are concerned about just plugging information into the cloud and OpenAI. You touched on it a little bit, but do you offer any kind of on-premise solutions where it's you can not have to worry about where the data goes?
Yeah. So basically, Valispace exists in two versions. One is a cloud version, one is an on-premise version. And on-premise can mean anything. Can be either actually bare metal, like in your server room, but can also be a private cloud. So we have some customers who put their ITAR in, I don't know, for ITAR data, for example, in GovCloud, or in other cases, into some other private cloud that they have. So the possibility is there to run Valispace also locally. What we're bringing out now is the ability to also run the ValiAssistant then locally. So that's a new thing. But we have customers who say like, okay, what is important is that all the key parameters and so on are stored, but you can look at the OpenAI privacy policy and it basically says like, okay, whichever thing we get after a week, we basically throw away that information. We don't actually train. So the difference is, when you use ChatGPT, for example, right, OpenAI will use that information to improve their data and to improve and to train their models. But if you're using the API through like a service like ours, they actually commit to not doing that. They commit to throwing away the data and to not actually like improving their models on it. So if you trust OpenAI in doing that, which a lot of companies do, then it's not a problem in the first place. if you want to be even more secure, you take our on-premise version, which soon will then have the on-premise local ValiAssistant running on a local model, so that the data even never leaves your server.
Okay, so that's a product that local AI ValiAssistant product uh, is a product that's coming in the next couple months or
Exactly.
years. Yeah.
It's actually like we have the first beta version out with our
Okay.
first customer. We're testing it now, and then basically should be available to more on-premise customers.
Okay. And have you spoken with like regulators, compliance people, um or just your customers on their comfort level of using kind of using the cloud version, OpenAI version? What's generally like the industry conversation around that?
I would say it's a half-half kind of situation. Um, there's a lot of companies who are very aware that their data is stored, like they're already using services like whatever, Dropbox, Google Drive, and so on, right? Like they say there's so much more value in using tools that connect everyone and being fast. The thing that I'm building today, tomorrow is anyways outdated. So even if there is a theoretical option that someone could, in principle, whatever, through some government or spying or something, get into this, is low enough for me to basically take these kind of tools on board, right? So there's these kind of companies, and I think they're actually quite a significant amount, right? There's like big companies who moved completely to Google Drive for their kind of documentation. There's companies out there that are using a lot of tools. I mean, we're all using whatever Zoom to have
Yeah.
conversations online
Yeah.
and so on. And I think the amount of trust into some of these corporations is quite high because they know that these companies have a lot to lose if they lost company data.
Yeah.
And then there's another kind of customers which, because of ITA regulations or their government contract or even internal regulations, they are just not allowed to put the data anywhere, right? Even if it would make sense, even if they say the risk level is very low, it's just their way of looking at the world, and we accommodate for those kind of customers from the get-go because we believe to date that's a fair assessment. If people believe that this is the case, who are we to tell them not to do it and not to be like more careful with their data? But yeah, it's a bit up to the customer to decide, and then they have a bit more work. They have to administer their own servers they have and so on, but they usually price that in. They know that this is what is important to their organization to such a level that they will sacrifice speed for it.
And when you talk to your customers, um, what is some pushback that you might get in implementing AI software and implementing like OpenAI LLM models? Obviously, I assume that people see the value add with it, but what are some of the pushback that you get with it?
Everyone who has done their job for 20 years will always be weary of someone coming around the corner and saying, hey, we can change your process, make it faster, make it better, right? I think that's a very natural human reaction. And I think we see that sometimes that very experienced people say like, well, but that's how we've been doing it forever and it was just fine. Like, why would we go and change this? But then even with these kind of organizations, I remember very well, we were sitting down with one of our customers at a big car OEM, and we basically showed them the feature of being able to break down requirements. And they had just gone, before we showed them, they had just gone through a phase the past weeks of breaking down all of their requirements. And I remember the chief engineer sitting there and he said, like, what do you mean? Like, we could have done this in like days instead of weeks, right? And you could see it in his eyes, like it became clear to him that wow, that makes such a difference. So in these cases, even the naysayers in such a team, they're gonna be challenged and be like, okay, I mean, I don't care how you do it, right? Just bring me those results fast. And the expectation is gonna be from every engineer, like it is now possible to do that in very short time. Like if you do it by hand, you do it with the AI assistant, be my guest. But the bar has just been raised, and I think that's what people will face, and I think that's fine, right? Like people being skeptical is a good thing, and I think engineers always wanting to look under the hood and actually trying it out is also a good thing, and that's why we decided, for example, to put on our website the ability to try out yourself. Like if you go to valispace.com/AI, you can actually try out yourself, just say what you want to build, right? Say like, I want to build, I don't know, a spacecraft that goes to Mars that has these properties and so on. and just see for yourself, right? And some of these results will be good and some of these results will be okay. And that's perfectly fine, but you'll get a feeling for, okay, what's possible, what makes sense to be done there. And then you have to make that trade-off for every specific task, right? If you're amazing at requirement writing and you don't need anyone to review your requirements, great, right? But if you want to put a junior person on it, you want that person to have help to not forget things and actually to like learn how to write better requirements. Instead of you supervising that person, have AI collaborate with that person and then just look at the final results.
We have another question in the Q&A box asking if the ValiAssistant can be applied to software requirements also.
For example, if you write a software requirement, we'll still make sure that it's better testable. We'll still be able to break it down and so on. I think when it comes to the system decomposition, today that's very much focused on hardware, right? So you'll have the electronic subsystem, and then you'll have the battery in this, and you'll have the board on the battery board part on it. So I would say on the systems engineering part, it's still very much like hardware and box focused, right? Like what would you find there? But on the requirements side, yes, like you can check those kind of requirements for inconsistency. So let's say you have one part says that the software shall switch off the spacecraft in case of this condition, and the other one says in another condition, it will actually find these inconsistencies too. And with this new feature of being able to like define your own custom actions in AI, you can even say, for me, a good software requirement, I don't know, contains assembly level code or contains these kind of things, right? So check if all the requirements are like this. So it's also a bit up to you to decide what your standard is, what do you want to see, and then the AI part can check for what your needs are.
Great. And a reminder again, if you want to ask a question, just put in the chat and we'll certainly get to it. And so this all kind of really you started implementing the AI maybe last year, and OpenAI really kind of came out and was public only 2 years ago. Was there, before the last couple of years, was AI being incorporated in space engineering at all, or is it really just like a very new and novel trend?
I mean, I think with LLMs we were really the first, right? Like OpenAI came out with ChatGPT December 22, and that's basically right away after like early January we started implementing, and we're one of the first ones on the market with it. I do think that other AI capabilities, like for example the ability to check on board with which image you want to like downlink and stuff like this, have already been started before. Like I've seen some thesis work from people who have been, even before the OpenAI part came out, already looking into LLMs and how this could be applied to requirements, and is there a way to like do quality assessments. I think what has changed is LLMs have just been one of these cases where the rate of change has been so much higher than for other elements of AI in this industry, right? So when we were at the time still in 22, we were trying out GPT-2, and the answers were okay, but it was more of a toy, right? It was this thing where you could chat a bit, get some. It wasn't even chat; it was like text completion. It would be nice, but you wouldn't have the feeling that this would help you in your daily tasks, right? It was also not clear that this would change so rapidly to be so much more useful. And I think that's what has like driven that change. So although AI has been there, we've even had a panel in our iteration conference in iteration 22 that you can still find online, and we asked a lot of leaders, right, about AI. It was interesting because they said, yeah, it's gonna play more of a role, but it's gonna be like a slow process to get there. And then suddenly LLMs came out and or basically became so much better, and suddenly you had extremely better results. And since then some of these models have been open sourced, and like more and more people have been building on top of it. And I would say the rate at which things are changing, we're internally in a chat in our company, we're tracking like the newest changes to the newest models to decide like which one we pick, which technology we pick. And literally every week there's a new paper out there, there's a new way of doing these things out there. And that rate of improvement has never been there before in the AI sector. especially when it comes to things that can be applied back to engineering.
And why is that? Why has that been the case? I mean, this is like beyond just engineering and space engineering. Why have we seen just such a rapid improvement in AI capability over such a short amount of time? Talking about 18 months, really.
For example, when you were trying to look at requirement quality, right, there were like 10 different ways of doing that before. There was even companies which were doing that, right? Requirement quality checkers. And they were all trying different systems, but basically they had like very specialized solutions that would like look for, I don't know, look for a must inside a requirement and say, oh, it should be a shell, right? It would be very low level functionalities, and then they would stack up these functionalities and it would have like 30 rules. And if you combine them, then you would basically get to a place which would be checking a requirement okay-ish, right? And I think the major difference was everyone believed that also LLMs would have that threshold. Like you would have to invent new things for each application from scratch. And then what with basically with the GPT-3 coming out, that was pretty much the turning point. They found that no, if you just put more computing power on the same logic, the results will be much better, right? They didn't change the method significantly. They just found out that there's these what is sometimes called emergent properties. So you have that same neural network, and now you just make it bigger, and suddenly it starts behaving in a different way. It starts having properties of being able to answer and being able to take perspectives and being able to be creative in new ways that we thought were not possible with this way. So I think it unlocked this ability. And then I think it was Facebook or Meta that basically gave the first of these models out into the open. And the same thing happened. So DALL-E came out and was like this closed source thing. And suddenly you had image creation models out there that were open source. And you could really see there's like 10,000 of people out there so interested in this technology that they have been making improvements. And I think that's the second element. So one, more computing power started to solve things, but then the second thing was open source access to some of these technologies allowed so many more people to tinker with it. And suddenly you have entire tool chains and capabilities of storing things in like these long chain RAG databases and so on. All of these kind of things came out that were not even possible before.
Great. Then we have in the chat about how we still have another 15 minutes, and we'll bring this up again, but I want you to plug, if you can plug your email address or how people can contact you. Sure. To set up a call. I'm sure that'll be fine with you for them to reach out, but what's your email address?
So just reach out to me at marco@valispace.com and or just go to the website, have the contact there. You can also find me on LinkedIn. I think there's quite a few ways of contacting me.
That's marco@valispace.com. Okay. And I'll bring that up again at the end of the webinar too. So just on the computing power, so AI is built on computing power, and the more the better the model is, the more computing power it is, and also the more expensive the solution is. So at ValiSpace, are you charging like on a token basis, where you charge based on how much AI capability someone is using, or do you have a flat fee, monthly fee that you just charge for unlimited access?
Yeah, what we found is that engineers just want to get their job done. Again, they don't care, is there an LLM behind it or is there none, right? So what we do is we charge a flat fee for people to use it. Of course, like we're monitoring and seeing that no one is doing other strange things with that kind of access. But today, this is part of our normal packages because we believe that as long as people use it in their engineering context, that's exactly what people pay us for, right? Like they pay us as a company to help them do engineering faster, and then it's up to us to optimize this with using different models, using different API calls, different other ways, and that should be abstracted away from the user. We don't want people to having to worry about those things.
Yeah, cool. And then what do you think the implications for the space industry are with these tools? How is it going to impact satellite development, deployment, cislunar economy? What do you see kind of the future space economy looking like now that we're able to leverage AI?
I really think that a lot of the things that we had on the roadmap as humanity of what to build next are just impossible to do on the old ways, right? Like I think, I mean, even before the AI part, right? Like if you want to build a lunar base and you're doing it like the LSIs with spreadsheets and copy pasting documents, you're not going to get there. It's too hard of a problem basically to do, and you can see like you can basically see this max out, right? So for example, when you look at, I don't know, how much it did cost to build and maintain the ISS, that's one of these cases, right? It's like that's currently like the best and most complex thing humanity can build on this traditional way of working, right? And I think then you have different like steps in between, right? So the first step is, well, what happens if you go away from these traditional tools, right? Like what happens if you don't wait to send in hundreds of documents for your CDR and then to get comments back 2 months later and then to have another loop and so on? What happens if you start doing iterative design, right? Like what happens if you have collaboration platforms? What happens if you do commenting real time? What happens if you do assessments real time? What happens if you share information across company borders? And I think that's the first step to unlock totally different efficiencies and ways to get somewhere. Now we have that second step with the AI. And I think that, let's say the AI capabilities today, even inside Valispace, they're just the tip of the iceberg, right? They are what you can do with the data as of today. And what gets even more exciting, right? Like, and so this makes all of you faster to get to these places. And then I think what we're going to see next is going to see how AI really helps you make decisions better, right? Like imagine you'll have an electronic board which you're using inside one of your spacecraft, right? And then the question is, all right, this manufacturer went out of business, right, for this specific part. So today that's like, oh, let's go back to the drawing board. Let's figure out what we do and so on, right? Source again, start verifying again. Now, if AI can help you and can say like, look, actually out of the millions of components that are out there, hey, I'm suggesting these three, looking at your requirements that you have, looking at what you're building, I'm actually going to suggest these three, and like this one is the one that will replace it. And now we're checking that back against your original requirements. We're also checking on all of your tests and seeing, okay, these three tests have to be repeated, those other ones not. If you can get this kind of information, right, of these things at your fingertip, suddenly that blowback is not such a big thing anymore, right? This would have like delayed your project 6 months, 12 months originally. So that now it might just be 2 weeks. So if you want to build all these beautiful things like Moon and Mars bases, if you want to have that kind of space economy, you have to build it up on these far more efficient ways of collaborating and on iterating, right? It's really about doing fast iterations. And I do think fast iterations rely on people being connected through the same tools, working on the same time on it. That's one big piece. And then the other part of iterations is really getting help as you're taking decisions, getting aid of making trade-offs and so on. You should not have to do this. And then even lastly, today, especially in space engineering, we're often stacking worst cases up on top of each other, right? So oftentimes you would like try to do a sizing exercise and you would say, well, let's assume the worst case temperature and worst orbit and worst this and worst lightning time and worst, right? Like you'll put them all together and then just size whatever you're building for that worst case. Why? Because it's just easier to look into all of these cases and how they're interrelated. But that means we're still oversizing quite a lot of things, right? Like we're not on the optimal point. And in space, where every kilogram counts, space where every optimization counts a lot, that makes a big difference, right? Like we have Mars rovers who happen to be there 30 years longer than they thought to. Well, that's amazing, right? I'm super happy that those rovers are still out there. But it means that we've oversized them, right? And if maybe we could have gotten them earlier out there, maybe 10 years earlier, and have the science done 10 years earlier, if we didn't try to optimize for these worst cases. So not only will it allow us to do the same things faster, but it actually allows us to get to better results, to get to more optimized results, to get to
Yeah.
better products basically out there that are made for the job.
Right, because it'll save you time, and with that extra time, you can explore 20 different paths instead of two different paths.
Exactly, right? Like make that trade-off not just between two of your subsystems that you're looking at, right? Like what would happen if you did electrical propulsion? What would happen if you use this sensor, but then you have that other part? It's all of these kind of trade-offs where today as humans we just have to say like, look, right? Like I've roughly looked at the envelope, let's stick to those options and figure it out. Just to move forward. And that's perfectly fine of a decision today as an engineer. But in the past, it would be more extreme, right? Like if you look back way into the past where people were still doing drawings by hand and calculations in rooms of people like doing that by hand, of course you would explore far less options because it would cost you so many resources. Today we have a computer and well, do Monte Carlo, find the optimal one, right? And that's okay. And now next up is to do the same thing in optimization on design and requirements and so on. You say like, okay, like just find the optimal combination of these things and give me a design that gives me a result that is much better.
Yeah, and by the way, the assistant might generate a bunch of ideas that you don't take. And you might realize that your first idea was the best one, but you can kind of cross out the different options and then be even more sure that the right option is the one you originally had.
Absolutely, but it's also not just the design phase, right? It's really like about, for example, one of these key questions is, oh, you have a new idea, like some new technology comes out and you want to implement it into your onboard software, right? Like you're saying, oh, okay, cool, right? By now this new chip comes out, there's an opportunity. We still launch only in half a year. Can we not take this one, right? It will have so much better capabilities. Today the answer will be no. We're too late in the process. No way, right? It's just far too hard to even assess which kind of tests we have to redo, what do we have to do? And tomorrow you're going to be able to say like, okay, like tell me what do I have to do, right? Like which documents need updating, which tests need to be rerun and so on. Now you can make a trade-off. Is that worth it, right? Should we do this? So it's even at later stages where you're suddenly opened up to doing more things and things that you had not in mind could be possible. I think there's this beautiful anecdote, right, where you had like why did the space shuttle have wings? And at least how one of my professors at uni told us, right, was because there was a requirement that if you snap pictures from Earth, they had to be revealed in a lab, and that lab you had to reach within like so many hours all over the world. You had to like land that spacecraft again and be able to bring it to the lab to then look at the picture and then be able to take decisions based on it. By the time the spacecraft was like ready to be like developed further in the development cycle, that didn't make any sense anymore. You had digital photography, so you could actually like do that already on board. But that requirement was like too late. It was still in there. You would still do it, and they would still have these massive wings, which then created all these other problems that we all know about with spacecraft. So it's really these kind of things, and if you're able to bring iteration cycles shorter, things make more sense once they come out.
Yeah, AI is developing very rapidly, and it will help engineers develop rapidly too. We have 5 more minutes. I want to kind of even step even further back and see if you think that AI would be able to discover novel physics or novel engineering, not just give you creative ideas of what is the best fit or is this possible X, Y, and Z, but come up with like brand new thinking that humans haven't discovered before.
Yeah, I think absolutely. I think it won't happen like by accident in our normal jobs, right? It won't be like, oh, I'm designing like this CubeSat and suddenly I find this new way of propulsion just because I used AI. But I think there's gonna be scientists who are gonna be working on propulsion systems. They're gonna be able to discover things that they didn't see before, right? Just take I think 2 weeks ago, something like this, there was an article that came out and was about there's the first time in 60 years that scientists have like found a new antibiotic. And like this is one of the big things in science, that like we have this beautiful thing, antibiotics, and it can like cure pretty much anything. But if this doesn't work, we don't have a plan B. Like humanity is really in a bad place if we don't have this. So people have been looking for antibiotics for a long time that could work. And now it took them 60 years to like find one. How? Well, they just had an AI that went through, I think, I don't know if it was 200 million or something like this, compounds, and just compared them and looked for properties that could be. And again, what did it do? It actually brought it down to like 200 options that then they tested in the lab. So again, the AI was not telling the answer, but was like taking this big list and bringing it down to 200 options. They tested it in the lab and they found two compounds which actually work. So same thing here, right? Like you're gonna have scientists that assisted through AI will be able to find new solutions to old problems. And because the AI is a great helper to do things that would usually be impossible just from a resource and timing perspective.
Yeah. And that would be kind of it's still the co-pilot method. And, if we fast forward not just 2 years, but 15, 20 years, do you still think that it will be a human in the loop, designer human in the loop, asking the questions and the prompts, and you'll still have an even more genius AI, but it will still be more of a co-pilot to humans and engineers?
I mean, call me conservative in this aspect, but I believe that sure, these AIs, like what we see right now, is they're now becoming agents that can a bit work on them by themselves, right? So they're interacting. So you'll have multiple AIs and they interact as agents between themselves. So you can now say, okay, look at these compounds, and whichever compound you find, like put this automatically into this lab, start doing these tests and so on. But still, you still have to figure out what are you asking for? Is this good what I'm seeing? Is there a different way of looking at it? So my feeling is anything that feels repetitive and where you're like, well, I guess that like it's just a matter of transpiration and not inspiration. These things will go away, right? So, and maybe today for a lot of jobs, even in the space industry, that might be 80% or 90% of what we're doing, right? But imagine where you could be if you just had to look at these 10-20%. For me, it's a bit like for whoever watched Iron Man, the movie, right? In the end, you have this guy and he talks to this AI and he's like, okay, what happened if we did this in carbon fiber, right? Like, oh, okay, cool. So let's figure out what happens if we like put a third leg on it and then do this and then do that. And you don't have to go through the calculations, through the drawings, through the whatever. You still have to figure out what you want, right? And you have like someone. And I think the only mistake that this movie made in this sense is here it's just for dramatic reasons, one single hero. So you have one person talking to the AI. But I really believe that it's more going to be collaborative effort. You're going to have like 3-4 people in a room, and together they're going to brainstorm. And whenever they're saying like, oh yeah, I wonder what happened if we changed the fuel mix ratio to a different one. Could we reach that, right? And then the AI says, well, this would be here, this and that. And then the thermal person comes back and says like, okay, is there like a material out there that could survive this part so that we can whatever? So I think you'll have these deep experts who have been there, done that before, being able to collaborate together with that AI. And I hope to really see that through being basically engineers in a room. And you almost go back to this idea of concurrent design facility that maybe originally is there as an idea, right? You'll have experts in a room, but now you'll have the AI sitting there with them. And they'll just throw off ideas. And in the end, you click a button, the documentation comes out of how to build it, and you give it to a shop and it gets machined. And that's it.
Yeah, definitely. I mean, it seems like if engineers or people aren't adopting AI this year, it'll be the year after or the year after that one, because the capabilities of these models are really, really impressive. But Marco, this has been awesome. I think a really, really great discussion. Can you plug your email address one more time and where people can contact you?
Yeah, absolutely. So marco@valispace.com is where you find me. Then go to valispace.com/AI to actually try the ValiAssistant. You don't even have to sign up. You can just try out what it looks like. Quick hint, put in as many details as possible on what you're actually trying to build. The assistant will then try to like take that information in and give you something interesting back. And in general, feel free to like reach out to us if you want to try this out, see this in your day-to-day work. And really curious to also hear if you have more ideas of what an engineering software that is AI powered should do for you. We're all ears to learn about like what your ideas and wishes are, so that when we arrive in the year 2030, we all have these capabilities we were all dreaming of.
Yeah. Great. Thank you. Thank you everyone for attending. Appreciate it.
Thanks for having me. Bye bye.
Bye bye.